Okay. Okay, so continue from where we left from group 1 presentation just now. So we covered on the multiplication rule, simple multiplication rule, and also on the rule, identity matrix. Okay, so for subtract and addition, I think that is pretty straightforward as what I mentioned just now. Okay, and then okay, so this is the identity matrix. Okay, you multiply by the same value by the matrix. Okay, and then you also got another rules. Okay, the idempotent matrix. You multiply both matrix the same, you still get the same answer. Okay, but my main concern is on the transpose. Okay, because this is needed when you want to solve for the using the determinant. Okay, matrix penentu. Okay, to get to solve for the unknown, okay, to find the value of a or x or y or x, y or z, okay, when you multiply the two matrix. Okay, okay, Azrina, so what do you understand by transposition or transpose matrix?
Besides, we find the in transpose, we also can find the same answers with the different column and row. I mean, for this question, the questions want us to find the AT, right? So besides, and the questions already given the matrix A with two row and two row and three columns. So we also can find in two row with three column with two columns.
Okay, so when you transpose a 2 by 3 matrix, it becomes 3, for example,
3
here.
times 2.
Okay, so the row become matrix, the row become column, the column becomes the row value. Okay, so
yes.
Okay, so 1, 2, 3, the row here now becomes column 1, 2, 3. It's quite straightforward there. Okay, inverse. Okay, so from transpose, then you can produce the inverse matrix. Okay, so once you understand the concept of transposition, okay, the row become column, the column becomes the row. Wait, okay, formula for inverse matrix. Wait. Okay, can you just explain this example here? Yang bunyi ayam. Rumah kat mana, Azrina?
Dekat Kelantan.
Oh, okay. Siapa yang belayam tu? Jiran ke ataupun sendiri?
Jiran.
Jiran. Okay, so this example here, okay, the application of inverse to solve the simple. So the inverse sign, okay, you have the power of -1 here, so that indicate inverse matrix. Okay, so when you want to write an inverse matrix, so A inverse 1, okay, so A by the power of -1, what we call it A inverse 1. Okay, so when you want to solve for equations, okay, X is the unknown here. Okay, so A multiplied by the matrix of X, okay, to get the B, which is the solution. So to solve for X, okay, so basically when you bring A to the right, okay, so basically is what the inverse sign is lah. Okay, so when you bring so to solve for X, okay, matrix A is brought to the right, so that is what we call the inverse matrix. Okay, so a simple demand, so when you learn demand and supply in principle of economics or even microeconomics, okay, in the next semester, okay, so this can also be solved. Okay, of course the easiest one, if the solution is simple, you can just use simultaneous equation, okay, but also can be done using inverse metric, okay. So can you go through this example here? Okay, because I need to, okay. Okay, Azrina?
Okay, so for this question, the questions one is to find the equilibrium price for each market. And the question's already given the equation. So the first one, we use the A X equal to B, and then we separate the A matrix, the X matrix, and the B matrix. And then we find the first inverse of A, which is we multiply cross at the matrix number, and then we minus the multiply cross in matrix number, and then we get the 646. And then can you scroll down?
Okay.
And then we can find the A, the power of -1, after we find the inverse just now. And then the A, the power of -1 will be exist, which is A, the power of -1 equal to 1 over D, D in matrix D, -B, -C, and A. And then
Okay,
actually we
kejap, apa tu, okay, first, the most important one, I mean, one of the important part is to calculate. So what is 646 again?
646 is from the multiply cross from matrix A, which is 18 multiplied by 36 minus -1 multiplied by -2.
Okay,
We
so
take from the matrix A.
so what do you call here, the, when you write this symbol here, so what do you call A here? I mean, this symbol here.
Inverse. Yeah.
Find the inverse of A. Okay, so yeah, so the inverse of A is 6 4 6. Okay, so the inverse of A is obtained by you know, you cross multiply and the main one is of course to minus lah. So you cross multiply the for 2 by 2 is straightforward because you simply multiply the, I mean, cross multiplication. Okay, but for a 3 by 3 matrix, okay, it is much longer to solve. Okay, so you get 646. Okay, and then okay, so why do you 1 over 646 here?
Because the formula is 1 over D, and then the D is same what the D is the inverse of A, so that's why we calculate 1 over D, which is 1 over 646. And
Okay,
then
so this is the standard formula. Okay, you call it the matrix penentu. Okay, or penentu apa, I'm not sure in but of course the English term is inverse matrix lah. Okay, so 1 over the inverse value. Okay, and then you cross value, and then so if you write A, B, C, D, so this is A, B, C, and D. Okay, so A and D will switch places. Okay, D and A. So I'm sure you've seen this formula before. Okay, so and then for A, I mean for this value and this value, okay, you multiply by the negative sign. Okay, so negative B and negative C. So for a 2 by 2 matrix, this is the way to do it lah. Okay, but for a 3 by 3 matrix, okay, it is much more complicated. Not complicated, but it take more steps to solve rather than the simple you know, changing places and then put the negative sign for the corresponding metric value. Okay, so this is basically the formula when you want to solve a simultaneous equation involving two unknowns, okay, X and Y. Okay, but when you are dealing with three unknowns, X, Y, and Z, okay, so the formula is slightly different lah. Okay, but for a 2 by 2 matrix, so this is the so of course first you find the inverse, which is the you cross multiply and you minus, okay, this value multiply minus by the product of the diagonal multiplication. Okay, and then you plug in into this standard equation here. Okay, D and A, you switch places, and then the rest. Then when you multiply by the, okay, so how do you solve for this? Okay, so, sorry. First, this one is the, so once you obtain the inverse of A, okay, basically this, okay, okay, inverse of A, so this is actually what the whole thing is what you call metric inverse. Okay, the inverse of A. This one is your determinant. Okay, so A, the modular sign for A, okay, is not inverse. This is the inverse of A is this one. A inverse is the product of A 1 over the determinant multiplied by this value lah. Okay, and then finally you get, when you multiply, and then you get 36 divided by 646. So basically so this answer here is what you call the A inverse. Okay, the inverse of metric A lah. Okay, so and then to solve for X, which what we mentioned here just now. Okay, to solve for X, when you bring A to the right, okay, you put as A inverse B. Okay, so basically in mathematics, if you bring this value to the right, it becomes B over A, kan? Correct? Okay, because this basically is A multiplied by X. So if you bring A to the right, basically it's B divided by A lah. Okay, so B divided by A, when you learn in the exponential formula topic before, B divided by A, if you want to bring A on the top, that's why you put A by the power of -1 lah. A -1 means 1 over A lah. Okay, but in matrix, A by the power of -1 is what also we call the inverse of A. Okay, but in terms of mathematics, this is nothing to do with matrix at all. Okay, so this is just a linear equation. A multiplied by X equals to B. So when you bring A to the right, so basically it's B divided by A. So when you bring A up, becomes the numerator. So you need to put the -1 sign, which is 1 over A lah. Okay, but when you see this from matrix punya concept, okay, A -1 is the A inverse. So to solve for A inverse, okay, first you need to find the determinant, which is the product of the cross multiplication. You multiply the two values to subtract. Okay, A multiplied by D minus B multiplied by C. Okay, so you get 646, and then you plug into this is only for metric 2 by 2. Okay, and then this final value here, 18 over 2323, and the rest is what you call the A inverse. Okay, and then you can solve for X, which is the A inverse multiplied by the metric of B. Okay, so A inverse is what you get here, because you cannot, this is the final value, because you cannot simplify anymore unless you get a decimal places lah. Okay, so and then the metric for B is 87 and 98, and of course this one is 2 by 2. That's what you see here. But B is 2 by 1, 2 rows and 1 column. Okay, so but you can multiply both because 2 and 2 are the same. Okay, and the product will be 2 by 1 lah. Okay, so I believe you learned this before. Just to recap, okay, in terms of matrix, so to multiply both, you must check that the column and the row of the side-by-side matrix are the same, so 2 and 2, and the product will be 2 by 1, meaning 2 by 1 is 2 rows and 1 column. Okay, so when you multiply, you should get the final answer will be 5 and 3 lah, which is 5 is referring to B and 3 referring to P lah, the value here, okay, from what you solve here lah. Okay, so of course this is done by using metric. Okay, this can also be done using simultaneous equation. Okay, you can eliminate one of the unknown and then solve for another unknown first, then you substitute to find the value for another unknown or another variable. So that one is using substitution method. Okay, if you're not using matrix lah. but if using matrix, so this will be the for a 2 by 2 matrix for two unknowns, P and X and Y, or P and B lah, two unknowns. So this is the way to solve for it. Okay, so let's see another. Okay, so this is in your exercise, kan? Correct?
Yes.
Okay. Okay, so can you go through this example quickly here? I mean, this question and answer quickly. Basically, it's the same thing here. So for today, we only focus on the 2 by 2 matrix. Okay. For next Wednesday class, okay, we're going to focus more on the 3 by 3 matrix, okay, for other groups. Okay. Okay, Azrina.
Okay, so for this question, the question wants us to find the value of P1 and P2. And the question is already given the equation. So the first one, we use the AX equal to B formula. And then we separate the matrix A, matrix X, and matrix B. And then we just cross multiply at the matrix A. And then we minus other number that we cross multiply. And then we get the 8. And then if find the inverse of A, can you scroll down?
Okay.
And then same just like the previous question before, to find the A, the power of -1, 1/8 multiplied by the matrix A, which is that we already swapped the diagonal elements. And then to find the P, we use the X equal to the A to the power of -1, B. So A, the power of -1 equal to 1/8. The A, the power of 1
Okay.
by the P. Get B for 1 for 30, 2.
Okay, so basically the process is the same. Okay, first you write in terms of the EX equals to B. So X is the matrix of okay, P1 and P2 lah. Okay.
Yes.
Okay, and then okay, so basically this is the first step lah. Okay. Okay, to write. Okay. So I think it's quite clear from the example. Okay, so first find the determinant. So this is what I mentioned just now. The modulus A sign stands for the determinant of A, which is the product of cross multiplication. Okay, and then once you get the determinant A, 8, and then 1 over determinant, and then you use the formula negative T, negative A, and then put the negative sign for B and C. Okay, and then the rest you solve for it. Okay, so I think this is quite a simple application for, okay, to solve for two unknowns. Okay, not only for P1 and P2, you can also use for P and Q, okay, price and quantity when you solve for equilibrium, okay, P and Q, okay, for in economics. So I think that should be for our today discussion. Okay, so for the rest of the groups, okay, for tomorrow, I mean for next Wednesday and the following weeks, okay, so most of the focus will be just going through the exercises on matrix T by 3, okay, so I don't think there is much to discuss in terms of the concept, okay, because the focus is basically using and another one using the Kramer's rule, of course, okay, is the shortcut to the long process if you are using the inverse solution. Okay, so depending on the questions, if you were to answer actual exam questions, some questions require you to use Kramer's rule. Some questions states that you must use the the inverse solution. So if you go and check past year's question in the library website, okay, you can get what I mean. Okay, for example, like this one, okay, it states that you need to use the Cramer's rule. The same apply in your exam questions. Okay, of course, there is no final exam questions in this semester because of the COVID-19. Okay, but so you need to know both lah in a way. Okay, how to solve for the unknowns. Okay, X and Y or Z using the Cramer's rule. So I think for the rest of the groups, so we just going to go through the same exercises. I mean different exercises. Hopefully that by the end of the assignment discussion, your understanding on the concept of matrix, either using inverse or Cramer's rule will be good. Okay. So thank you for today. And I'll see you on next Wednesday. Okay, thank you. Assalamualaikum and good morning.
Thank you, Dr.